understanding the equipment. Diagnose, replace, and relearn the tire pressure monitoring system.
Safety first. When working in the shop, always follow the safety guidelines provided in service information, tool operation manuals, and other technical literature. To protect yourself from injury, wear personal protective equipment, PPE, dress appropriately, work professionally, and correctly handle tools and equipment.
Correct tire pressure is crucial to vehicle handling, ride quality, fuel economy and tire wear. This has made tire pressure maintenance an important safety issue throughout the automotive industry. The Transportation Recall Enhancement, Accountability and Documentation, or TREAD, Act was introduced in the fall of 2000. The law mandates that a tire pressure monitoring system be included in all vehicles beginning with model year 2007. The purpose of a tire pressure monitoring systems TPMS is to warn drivers if their tires are losing air pressure. Underinflated tires can lead to dangerous conditions. There are two types of tire pressure monitoring systems on the market, direct and indirect. Having an understanding of these systems is important when performing tire service. The most commonly used system is the direct system. This system uses a pressure sensor or transmitter mounted to the vehicle's wheels to transmit a pressure signal to a receiver located in the vehicle, which in turn will illuminate a warning light on the instrument cluster. The tire pressure monitor, TPM, checks the inflation pressures in all four tires at frequent periodic intervals. When the system detects changes in any tire's inflation pressure, it responds by triggering a warning lamp on the instrument panel. The indirect system uses the vehicle's wheel speed sensors to compare the rotational speed of the four tires. When tire pressures increase or decrease, the tire will roll at a slightly different number of revolutions per mile than the other three tires. When the computer senses this difference, a warning lamp will illuminate. Unlike the direct system, an indirect system cannot tell the driver which tire has low pressure. The tire symbol visible on the instrument cluster will indicate if a vehicle is equipped with TPMS. The service information will indicate if the system is direct or indirect. Early direct TPMSs used an aluminum valve stem that was bolted to the wheel. The sensor and the stem would be replaced as a unit. Some manufacturers used a banded sensor that attached to the drop center of the wheel and used a standard valve stem. The style can be difficult to identify without service information. Later models started to use rubber pop-in valve stems because of the corrosion issues that came from the aluminum bolt-in sensors. The style can sometimes be identified by the slightly taller valve stem cap or a gray-colored cap. With this style, the sensors became serviceable without replacing the whole unit, which was a cost savings to the consumer. The TPMS warning system can vary from a warning lamp to a graphic display that shows which tire is low on pressure. Some systems allow the driver to monitor current air pressure of each tire. If the power control module, PCM, detects a problem with the TPMS, a warning lamp or message will appear in the instrument cluster. After tires have been rotated or replaced, the system may need to relearn tire position. During this time, a message or warning lamp will be illuminated. Once the relearning process is complete, the message will turn off. Diagnosis of TPMS problems varies from manufacturer to manufacturer. A thorough understanding of the system being used is very important. A TPM sensor tool is a wireless tool used for diagnosing sensors and allowing the tire positions to be relearned. The tool can be used to reset the system, which may be needed after tires are rotated, tires or wheels are replaced, or repairs are made to the system. The tester activates the sensors and the transmitted data from them can be observed. Most systems require placing the tool near the sensor and then activating the sensor via the tool. Now enter the simulation for more on tire pressure monitoring systems.